Well, actually, I'll show you three different ways to do this. First, there's the simple, straightforward approach. You just calculate the binomial probability of getting 2 successes, or 3 successes, or 4 successes, or 5 successes, or 6 successes, or 7 successes, and you add them up. Okay, well, that's the straightforward way to do it. So let's select that and okay, got that selected, and then we go up here and we hit the run button and we get 0.9375. Okay, that was the simple, straightforward way to do it. Maybe that's a brute strength approach and it's not the most clever. Um, Let me look at this second approach down here. What I'm doing here is I'm calculating the binomial probability of 0 successes and adding it to the binomial probability of exactly 1 successes. Well, that's the opposite of what I'm looking for, but the opposite in effect solves the problem for me because the probability of the event plus the probability of its opposite, or technically what we call the complement, those two probabilities have to add up to 1. So all I do is calculate the probability of the complementary event and then subtract that from 1. And let's make sure that that in fact works and produces the same result. Yeah, 0.9375. That complementary events trick is a really important thing in doing probability type problems. Okay, then let me look at another approach to it, and here I've done something funny with the dBinome function. Notice that what I've inserted here is 2:7. So that's a vector. It's a numeric vector, and it consists of the numbers 2, 3, 4, 5, 6, and 7. And instead of just putting a simple number in the call to dBinome, I put a whole vector of numbers. Well, let's run that and let's see what happens. This isn't actually going to be our solution, but it gets us real close. What you get is there's the probability of exactly 2, there's the probability of exactly 3, exactly 4, exactly 5, etc., etc. So if you could just add all of those up, what you would have is the original number, 0.9375. And the way to do that is to take this call to the dBinome function and put it inside and call the sum function with the results of the call of the dBinome function. So let's run that and see what happens. Yep, 0.9375 again. So in addition to the simple brute force approach, I've shown you two tricks to do it. One based on probability theory, calculating the probability of the complementary event and subtracting it from 1. And the other trick is basically an R-based trick where you use a vector in place of a single number and then sum up the values in the vector. Okay, I hope that was entertaining and maybe informative and educational and all that good stuff.